Hello everybody, this is Mr. Yan, and in this video I'm going to be walking you through lesson 8.5, and I want you to watch this video after you've done as much of the lesson as you can. So if you're watching this video first, go ahead and actually pause it, do as much as you can, and then come back to this video to check your work or to get help in any places that you were stuck. In this lesson, we have the same two runners, Fernando and Mariah, and they are tracking their laps at different time intervals. Let's take a look at week 2. In week 2, it's telling us that Mariah had completed 15 more laps than Fernando, and they run at the same rate. So the key piece here is it's 15 more laps than whatever he has. So then I know if at 0 minutes, Fernando already had 50 laps, Mariah would have 50, but 15 more than that. So I just have to do 50 plus 15, so that gives me 65. And then the other piece of information is it tells us that they run at the same rate. So they run at the same speed. And so then there's two ways that I can fill out the rest of the table. From looking at Fernando's data, I know that every 10 minutes, Fernando runs 6 laps. So if Mariah's running at the same rate, then every 10 minutes, she also runs 6 more laps. So I just have to do 65 plus 6 more laps to get to 71. And then another 10 minutes goes by, so 71 plus 6 more laps, 7 plus 6 is 77. And I can continue to fill out the rest of the table that way. The other way that I can fill this table out is I always know that Mariah has 15 more laps than whatever Fernando has at a given time interval. So I could just take 68 and then add 15 to get to 83, which is the same thing that I would have got from just adding 6 onto this 77 laps, because 10 more minutes passed. Okay, so then using either one of those two methods, I'm going to fill out the rest of this table. Yep, and just double checking that every one of these numbers is 15 more than the number right above it. Okay, next, write the equation for Mariah as a transformation of Fernando's equation. So the way that I want to think about this is Mariah's number of laps, that's m of t, is always equal to Fernando's number of laps at a given time, but what? Right? How do I have to change Fernando's data so that it equals Mariah's data? Well, I know that at any given time, Mariah's number of laps is always 15 less than whatever Fernando's is. So I can say that Mariah's function is equal to Fernando's function, but it's always 15 less than that. So subtracting 15 from his number. Okay. Next question. At 30 minutes, how many more laps had Mariah run than Fernando? Well, at 30 minutes, she had 83, he had 68, she had 15 more. Okay, what about at 60 minutes? At 60 minutes, he had 86, she had 101, she had 15 more. She always has 15 more laps at any time interval. So I can just say at 30 minutes and at 60 minutes, she had 15 more laps than Fernando. Okay, now let's look at week 3 on the right. For this week, Fernando's equation is f of t is equal to m of t plus 30. Remember, f of t is Fernando, m of t is Mariah. So what does this equation about Fernando tell us? Well, we know that f of t, which is his number of laps, is always equal to Mariah's number of laps, but he always has 30 more. So I can say Fernando always has 30 more laps than Mariah, and because and we know that they're running at the same rate too, so it always has 30 more laps than Mariah, and they run at the same rate. Okay, next, so let's complete the table. So we're given Mariah's information, that's here in red, and then I have to fill out Fernando. To do that, I can go back to this equation here. I know that Fernando, his number of laps is equal to Mariah's, but it's always 30 more. So that just means I can take, at any time interval, take Mariah's information, which is 45 laps at 0 minutes, and then add 30 to that. So 45 plus 30, that's how I get to 75. And 57 plus 30, that's how I get to 87. And I can continue to fill out the rest of the table that way. Or I can figure out what the rate is. So I know that every 20 minutes, Mariah runs the difference between 45 and 57. So that's 12. So she runs 12 laps every 20 minutes. So going from 20 minutes to 40 limits, I can add 12 to 87. That would bring me to 99. And then add 12 again. That brings me to 111. And then here I have to be careful though, because it's not a 20-minute interval. It's going from 60 minutes to 70 minutes. So instead of adding 12 more laps, I'm going to add half of that, 6 more laps. So adding 6 to 111, I get to 117. I can also just add 30 onto 87. 30 plus 87 is 117. That works. 30 plus 81 is 111. That works as well. Fernando's is always 30 more than Mariah's. So let's write an equation for both runners in slope-intercept form. Remember, slope-intercept form is y equals mx plus b, or f of x equals mx plus b, where m is the slope, the rate, and b is the y-intercept, how much they start with. So Fernando, to figure out the slope, I know that every 20 minutes he runs this difference. So the difference between 75 and 87, that's 12 laps. So it's 12 laps every change in x, which is 20 minutes. So 12 laps every 20 minutes. So that's our slope, 12 over 20. Plus the y-intercept, at 0 minutes, he had 75 laps. Just like that. And I can simplify this fraction, 12 over 20. I can divide both numbers by 4. So 12 divided by 4 is 3. 20 divided by 4 is 5. Okay, so there's Fernando. Mariah, I could go through the same process of calculating the slope, but I actually already know that they run at the same rate. So I can use the same slope, 3/5. Or 3 laps every 5 minutes. Oh, you know what? Let's change this variable to t, because we're saying f of t. So 3/5 times t. 3/5 times t plus the y-intercept. At 0 minutes, she had 45 laps. So there's her equation. So notice both of these equations, they have the same slope of 3/5, but they have different y-intercepts because they start at different numbers of laps. Write an equation for Mariah transformed from Fernando. So I have to think to myself, what do I have to do to Fernando's equation so that it's equal to Mariah's equation? So I know that Mariah's equation is going to be equal to Fernando's equation, but we have to modify Fernando's equation. Well, we know that Fernando's equation is always 30 more than Mariah's. So then to take Fernando's numbers and get to Mariah's numbers, I would have to subtract 30 from his in order to get to Mariah's. Right? If we're starting with 75, if I take 30 away from that, then I would get to 45, which is Mariah's number. So I'm saying Mariah's is equal to Fernando's minus 30. Her number of laps is always 30 less than Fernando's. Okay, let's look at the next slide. Week 4, Mariah recorded her running data on the graph on the right. So she's this red line here. And it's telling us that Fernando's equation is this. So I can read this as Fernando's number of laps at any given time is always equal to Mariah's number of laps at any given time, but 10 less than that. So he always has 10 fewer laps than Mariah has. Well, we can use that information to graph. So let's go to the line tool. At 0 minutes, instead of 40 laps, he's going to have 30. And then I can use these anchor points. So at 25 minutes, Mariah had 55. So I'm going to take 10 away from that. So that means at 25 minutes, he has 40 laps. And I'm going to continue that slope. And I want to make sure that the line is always 10 units below Mariah's. And they're running at the same rate, so it should have the exact same slope. They should be parallel. That looks pretty good. Let's add a color. Let's make Fernando blue. We can make it a little bit thicker like that. Okay, so blue is Fernando. That's that. Number 8, write the equation for both runners in slope-intercept form. Okay, so Fernando, what is his rate? What is his slope? I'm going to use some anchor points for this because if I just go by 5-minute intervals, it's hard to tell exactly how many laps we are here. So you don't have to do exactly what I'm doing, but I'm going to show you, I'm going to add in a slope triangle just to make it a little bit easier for you to see. Let's put in a rate triangle. So if I look at this slope triangle, which is not quite working out the way that I want it to, sorry about that. There we go. Okay. And I'm going to use this as an anchor point because I do know that at this point right here, it's exactly 25 minutes and 45 laps. So I can look at the difference in y and the difference in x between those 2 points. So I know the change in y between those 2 points, I'm going from 45 laps minus 30 laps. So the change in y is 15. That's the first number, the numerator of my slope. The change in x is this part right here. So we're going from an x of 25 and an x of 0. So 25 minus 0 is 25. Okay, so I know that this is the slope for Fernando. Y is laps, x is minutes. So I know he's doing 15 laps, right, every 25 minutes. Okay, I'm going to delete that for now, just so it's a little bit cleaner. That's my slope times t plus the y-intercept. At 0 minutes, he had 30 laps. 15 over 25 is a fraction. I can simplify that. I can divide both numbers by 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. So 3 laps every 5 minutes, or 3/5 times t. For Mariah, I know she runs at the same rate, so it's going to be the same slope. 3/5 times t plus, and her y-intercept at 0 minutes, she has 40 laps. Let's just compare these two equations for a moment. Notice that they have the same slope because they run at the same rate. And then Fernando's y-intercept is 10 less than Mariah's intercept. That's the same thing we have right here. Fernando's is equal to Mariah's, but always 10 less than that. So the y-intercept is also going to be 10 less. At 0 minutes, what was the difference between Fernando's and Mariah's laps? Oh, that's what we just said. Fernando has 10 fewer laps than Mariah at 0 minutes. At 45 minutes, what was the difference between Fernando's and Mariah's? What 45 minutes? That's right here. We see that he also still has 10 fewer. Fernando has 10 fewer laps. He's always going to have 10 fewer laps at any time interval. So how are F and T and M and T similar? We know that they have the same slope of 3/5. How are they different? F of t is always 10 units below m of t. Fernando is always 10 units below. I can also say they have different y-intercepts. So same slopes, but different y-intercepts. Okay, let's put this all together in a general rule. If f of x and g of x are both linear functions, and we know that f of x is equal to g of x, but plus k, how are they related? We know they have the same slope. So I can say f of x and g of x have the same slope. So we can go one step further. If they have the same slope, they're parallel. But, right, if f of x is equal to g of x plus k, that tells us that we need to add k to g of x in order to get to f of x. So I can say that, but f of x is always k units above g of x at any x value. Yeah. Okay. So that's the general rule of translated linear functions. And with that, I will say goodbye and good luck.